Okay, so today we are still looking at bivariate data, but we're going to be looking at when we have two numerical variables. So my example that I gave you the other day was as an example of that, where I said we collected the heights and weights of all of you. So they're both numerical pieces of information, and if you look at that, we said that your height would be the explanatory variable because you couldn't change that, it's independent. And we said, say, the weight was your response variable. So what we're going to see is we're going to plot them on a graph, and because they're both numerical, so along the axes, you see this scatter plot. So one of these little dots here would be an individual, and say their height was, 1.9 meters, and their weight might have been, 95 kgs, yeah? So all those dots would be individual people. So that's called, when you have these dots, it's called a scatter plot. Okay, so when we construct a scatter plot, the vertical or the y-axis is the response variable and the horizontal is the explanatory. And remember what I said, that explanatory, you can remember it's got the x, okay? But in your physics and your chemistry and all that, and bio probably, you know the explanatory as independent and you know the response as the dependent, so that might help as well. So we are going to draw these, or we get given these scatter plots, and we then are going to comment on, we get this scatter plot and we've worked out what the response variable, explanatory variable, and we end up plotting these graphs. So we then talk about the form. So when we go to describe these graphs, we'll talk about the form. Now the form is whether it is linear or non-linear. So this one, I would suggest that I've just drawn. It sort of seems to be, most of the dots are following this straight line pattern. So I would say this one's form is linear. Okay, if I drew another one and I might say, so response, explanatory, you might see your dots doing something like that. So they've got a different pattern. You can sort of see that. For further maths, all we have to say that it is non-linear. For those methods, kids and all that, you'd be looking at that and hopefully seeing maybe a quadratic or something like that, yeah? So us in further, we just want to know whether it's linear, sorry, I can't even spell that, linear or non-linear, okay? That's all we need to know, because mainly we are going to deal with it being linear, and later on down the track, when it's not linear, we're going to change it so it is, and therefore, as I said, we're only dealing with linear. So the other thing we'll talk about is the direction. When you're describing your scatter plot, you'll say the direction, and that's saying whether it's positive or negative. This one is actually a positive direction. Why is that? Because it's going up, the gradient, you can see. If you had one that was going down like that, the pattern, that would be a negative graph one. So there's another thing you'll comment on. And then the last thing we'll comment on is the strength of it. And what that actually means when we're talking about the strength is, if you have your dots, so say they're all nice and close together, see how they're nearly following a straight, they're nearly all going on to an actual line. That would be a strong relationship, yeah? If you see your dots and you get this bit more sort of random, but like that, so say, they are following up, but they're a bit more spread out, so that's when we wouldn't say it's a strong, it's a moderate. So what do? We actually can use our calculator to calculate a value, and it's called the R value, or we call it the correlation. The guy that invented it, Pearson's, so sometimes they use his name in it as well, that correlation coefficient. and that is the R value there. Okay, so we've got a way on our calculator to get this R value, and we can then categorize whether it's a strong, moderate, or weak one, and we'll look in the next page in a minute. But I can't remember. So the way they actually calculate this R value is they're looking at how far these dots are actually all apart from each other, away from your line of best fit, sort of like that. So can you see, and that's part of the calculation. You don't have to worry too much how it's calculated at the moment, but that's how it's done. So we are going to go onto our calculator and we're going to construct a scatter plot, and I'm also going to show you how to get the correlation coefficient. So we're going to use this data. So I'm going to pause the video and we're going to go onto the calculator thing. So we just went into lists and spreadsheets on our calculator, and we typed the two lists in, and we did do the scatter plot. But now I'm going to remind you how we got the R value. And we were on the lists and spreadsheets screen. So we're on lists and spreadsheets, and we have our two lists in there. So you'll have your EV list and your RV list, and you'd have all your numbers listed down in there. And then the way we went and got the R value was we pressed menu, stats, stats calculations, and then we went to linear reg, and it was the A plus BX one, okay? And we got asked to pick our X list, which is where you would put your EV. So for our example, we put test 1. And we also need to put our Y list in, which is your response variable, and for us it was test 2. And then we just went down and we pressed enter, and it ended up all the data was listed down here, and we got an R value of 0.9. Okay, so what we're going to do now is flick over to the next page, and we're going to see how we can categorize that now. You can't see it on the overhead, but can you see down the bottom it says never sort by variant data? Can you see that down on your notes on that page? What that means is, you know how if we put the list into our list and spreadsheet, see this test 1, test 2, that's actually a person, yeah? That's someone's score. So if you sort those lists, the right one's not matching up with the same person, yeah? And the same if I did your height and weight, if you sorted that data from, let's say, lowest to highest, that's not going to work, is it? Because then the weight of that person's not matching up. So you never do any of that. If they ask you to calculate the Q1, Q3, all that, you just go into lists and spreadsheets and just do stat calc. The calculator does it in the background for you. So never sort it, just to let you know that. Okay. All right. So the strength of the linear relationship, or the strength of a scatter plot, is given by calculating the Pearson's correlation coefficient. Okay, so it's written there anyway, sorry. Coefficient. Okay, so here I've just given you some examples, just in case sometimes they do just ask you to estimate it. So you've got a few examples. If you have an R value of 0, there's no relationship. So can you see all the dots are everywhere? Okay, if you have a perfect linear relationship, so you can see that this line is a perfect straight line, you get an R value of +1. So positive 1 is a perfect positive linear relationship. You can see if you have a perfect negative, you get a negative 1. So what that tells us is that the R value will always be somewhere between -1, so if you're at -1 on your number scale, and number 1, yeah? So here there's no relationship, And obviously at 1 it's a perfect positive, and here's a perfect negative, or perfect negative. Okay, so in between you can have a look. So if you have a look down here, we've got a negative 0.7. It looks something like that, yeah, and things like that. If we look here at this negative 0.3, that's getting very close to not really being related in any way. So you can see it's getting very spread apart. So we can actually determine without just having a look, and we can actually use our R value. So on the page before, we found a R value of 0.9. So can you see it fell into this category? Would you agree? Yeah? 7.75, it's a number in between those numbers. So I would have said that that one was a strong, positive relationship. Okay? So when this strong is the R, really, the strength. You're commenting on the strength. This positive is you telling the direction. And then the form would be, you'd have to say it's linear. All right, so to use, just reading down here, to use the correlation coefficient, R, is as a measure of strength of a relationship. There's a few things, if we want to use this and say we're going to use the R value, we have to have these things happen. So the variables must be numeric. Well, we couldn't do it. If we didn't have 2 lists of numbers, we couldn't get it, yeah? So that's that one. Now, the relationship has to be linear. So if you're going to quote the R value, we are saying it's linear. So they'll often say what assumption is made. So when you find the R value, you are making the assumption. Now, take note of that word, because they love to use it, that you are making the assumption that the relationship is linear. So is linear, okay? So you'll hear some questions with that. So just remember that. And there's no outliers. That's another really crucial point, because they might ask you, calculate the R value, and so you go and do it, and then they'll go, why shouldn't you use it? And there would be because you have a scatter plot that looks like this with this one out here, yeah? And why wouldn't you use it, and why wouldn't we use the R value? Remember before I said it takes in all the distances? This one's going to throw it off. It'll throw it off. It'll make it look weaker when it's not really. This was just our, like our big girl, our outlier, yeah? Not really what the trend is. So there's things like that, okay? So you're going to go and practice this. This will be exercise 3C.